Hello, and welcome to the tutorial on money market quoting conventions. The term money markets refers to the market for debt with a maturity of less than 1 year. In one sense, these are very simple financial instruments. They typically have no intermediate payments, and so everything is due in one single cash flow at maturity. But differences in the way interest rates are quoted for different types of money market instruments and for the same instrument types in different countries can be an obstacle to understanding and using these instruments. In this tutorial, I will attempt to explain and interpret these various quoting conventions. First, in virtually every case, money market interest rates are quoted as a simple interest rate per annum, that is, not compounded. This is different from the convention in bond markets where rates are quoted on a compounded basis, usually annual or semi-annual. For example, 12% per annum simple interest for one quarter of a year, means interest due at maturity would be simply 0.25 times 12%, or 3%. And if it were being quoted for 1 month, 1/12 of a year, that 12% would just be multiplied by 1/12 and would be 1% paid over that 1 month. Now, while these rates are quoted the same, note that on a compounded basis, they would be different because in the case of the instrument that would be paying in 1 quarter, you'd be getting 4 of those per year, whereas in the case of an instrument that was paying after 1 month, you would be getting that every month. And so you would be getting interest on interest, and that's not reflected in the simple interest rate quoting. Another source of variation is how days in a year are counted. And typically this would be 360 days or 365 days. Now it's important to notice here that of course an actual year is 365 days, but this refers to the way in which the interest is converted from an annual per annum quote into a daily rate or a rate over some period of several days. We'll get to an example of this in a moment. Another difference is the interest basis, and this really has to do with whether the interest is paid on top of face value at maturity or is actually taken as a discount from face value to reduce the amount borrowed or to reduce the purchase price. So let's deal with each of these in turn. What does days in year convention actually mean? Well, as I mentioned, there are 2 common ways of quoting this: looking at a 360-day year or a 365-day year. So consider a 10% quoted rate in both cases. And suppose that we were going to earn that for 91 days. So if we had a 360-day year convention, what that would mean is that 10% quoted rate would pay out for a fraction of a year represented by 91 days, the number of days we'd be getting paid, divided by 360 days assumed to be in a year. So we're actually getting a little bit more than a quarter of a year, even though 91 days is slightly less than a quarter of a year. And so the interest for the quoted period, 1 quarter, 91 days, would be 2.53% in this case. Now, if another instrument, also with a 10% quoted annual rate, were being quoted on the basis of a 365-day year, which of course is the actual number of days in a year, in that case, the fraction of a year would be 91 over 365. So that same 10% would be paid for that fraction. So it's a smaller fraction, and so we'd be getting a lower rate of interest for that quoted period, 2.49 versus 2.53% in the other case. Thus, for the same quoted rate, we're actually getting slightly higher interest if it's quoted on a 360-day year basis versus a 365-day year basis. Now, the other difference in quoting convention is the interest basis. What does this mean? Well, interest at maturity is the more conventional way of looking at it, and this is really like bonds are quoted. Interest is paid on top of a face value at maturity. So if the quoted rate were 2% of face for, say, a period, and we had some investment amount, V naught, And that would mean that we would get a payment at maturity equal to 1 plus that 2% times that face, and that would be our VN that we would get at maturity. And so our period return would be just VN over V naught minus 1, which would work out to 2%. So the 2% quoted rate would actually be the period return. Now, the other way this is sometimes done in the money markets is it's quoted on a discount interest basis. And what this means is that the face value is actually paid at maturity with no extra interest. In fact, the interest is taken as reduction in the face value at the beginning of the period. So the amount borrowed in this case is not the face value, but it's the face value minus the interest. So if we had the same quoted period rate of 2% of face, in this case, our investment V naught is not going to be face, it's going to be face times 0.98. That's 1 minus 2%. And the payment at maturity would be face. And so the period return in this case, using the same formula, Vn over V naught minus 1, is going to be 1 over 0.98 minus 1. So that's going to be 2.04%. So effectively, we're getting a higher effective rate for the period because we're getting paid the interest up front. Now, these two charts just show how these conventions are applied in various markets and with various types of instruments. So for example, in two of the major markets in the US and the Eurozone, 360-day year conventions are the standard. But in Canada, Japan, and the UK, 365 days are the standard. And then in terms of the interest basis, Treasury bills, which typically are one of the most liquid markets in any market, and certainly in the United States, those are quoted on a discount basis. Commercial paper, which are effectively Treasury bills issued by corporations, are also on a discount basis. But certificates of deposits issued by banks, interbank deposits, Fed funds in the US, and repurchase agreements, those are all paid on the basis of interest paid at maturity on top of face. So how do we compare money market rates for instruments with different conventions? There are two common standards that are employed. One is called the bond equivalent yield. The other is called the effective annual rate. So let's look first at the bond equivalent yield. This is just the simple uncompounded interest annual return, and it equals the period return times the number of such periods in a 365-day year. So if we had a return for some period of n days, then the bond equivalent yield would be just that return for that less than 1 year period multiplied by the number of such periods in a year, which would be 365 divided by n. Now the effective annual rate, different from the bond equivalent yield, actually looks at this on a compounded basis. So we would take that period return and we would compound it for the number of such periods in a year. And so that gives you the formula shown here, where you take 1 plus the return taken to the power of the number of such periods, subtracting 1. So let's look at some examples. First, let's look at the simplest one, really, we could design, which is an instrument that would be quoted on an interested maturity basis with a 365-day year. And this is the convention in the UK for a British pound CD. So let's say the interested maturity basis the interest is quoted on that basis. It's 10%. The days to maturity is 91, and that's going to be related to days in year of 365 days. Let's just say the face value is $10,000. So how would we calculate the interest in this case? Well, interest is calculated here. So we would take the fraction of the year, 91 days, which is the number of days to maturity, divided by the number of days assumed to be in a year by the convention, which is 365. We would multiply that fraction by the per annum rate, and then we would multiply that by the face value. So this gives us the amount of interest, $249.32. Now the investment up front, V naught, is going to just be 100% of face in this case, so that's $10,000. The value at maturity will be face plus the interest, so we will be getting 10,000 plus the 249.32, and that's given here. So if we were to look at this in terms of discount factor, well, that would just be the ratio of the amount that we're paying divided by the amount that we're going to get at some future date. And that's given by this figure here. The return over the period is a similar calculation, but here we're looking at the ending value divided by the beginning value. And to make it a return, we subtract 1 and we get our 2.4932%. Now, how do we convert this into our two standard conversion rates? Well, remember we were looking at bond equivalent yield and effective annual rate. So bond equivalent yield is the one that's done on a simple interest basis. So we would take our period return and we would multiply it by the number of periods in a year. So if there's 91 days that have passed for this instrument or till the maturity of this instrument, and there are 365 days in a year. Now notice this is the 365 days in an actual year, which happens to be the same in this case as the convention. So because it's the same, when we multiply it by the number of periods, we get back the quoted rate, 10%. But if we look at it on an effective annual rate, we need to take account of compounding because we're getting this 2.4932 every 91 days, and there's this amount of periods in a year, slightly more than 365 over 91. So we need to compound it for those number of periods, and because we're getting interest on interest effectively, that becomes 10.38% on an effective annual rate basis. Now let's look at case 2. So what's changed here? We're still going to look at it on an interest at maturity basis, but now we're going to deal with an instrument that has a 360-day year convention, such as would be used in the US for a bank certificate of deposit. So let's keep everything else the same. So interest at maturity, the quoted interest rate will be 10%. And again, that's on an interest at maturity basis. The number of days is 91. But now that's based on a 360-day year. Face value is still 10,000. So the dollar interest is actually going to be different, and that's why this is bolded red here, to reflect that it's a little bit different. So it goes up to 252.78. And why is that? Because we're dividing this 91 by 360 instead of 365 in the previous case. And so we get a slightly higher dollar interest. Face value is going to be the same, but the value at maturity is going to be slightly more, reflecting the higher interest. That's going to then be reflected in the discount rate, which will be a little bit different from the previous case. And the return will be a little bit different, a little bit higher, 2.5278, again, different than the previous case. And then these calculations are done the same as before, but now notice here, we're still using 365 both for the bond equivalent yield and for the effective annual rate, because these are based on the actual number of days in the year, not based on the convention. So when we convert this instrument and calculate its bond equivalent yield, we actually get 10.14% instead of 10% in the previous case. And the explanation for that is we're actually getting more days of interest effectively. And then similarly, when we compound it, we're going to get a higher rate, also reflecting the higher return for the period. Okay, let's look at the last case, this direction, case 3. So here we have an instrument that's on a discount basis and also on a 360-day year, and this would be the convention for a US T-bill. So we're going to have the same 10% quoted rate. We're going to have the same 91 days, so that's the same as in case 2. Notional amount's going to be 10,000. Interest is going to be the same, actually, as in case 2, because we're doing 91 divided by 360. That's our fraction of a year. So that doesn't change. What changes is when that interest effectively is earned. We get the interest up front, or when it's paid. So it's subtracted from face. So instead of getting $10,000 as our investment, we have $9,747.22, and that's just 10,000 minus the interest. And then at maturity, we're going to get 10,000, not 10,000 plus interest. So effectively, we're getting the interest here, not here. And so the discount factor will reflect that, and that'll be slightly different. The return over the period will be slightly different as well. And the bond equivalent yield and the effective annual rates will be different. Okay, so if we want to group these all together and compare them, this table does that. So this just shows the interest basis, the comparison of the three cases, the days and year convention, the face value, the rate quote. So these are all the same. This is where the differences are in the quoting conventions. And because of that, we get different interest reflecting the days and year convention. These will be the same. The investment will be different here, reflecting the fact that the interest is taken as a discount. And then the period return is just going to reflect what the interest is and when it's paid. And you see there are slight differences in the interest. And then when we convert that to an effective annual rate, those will be differences. And the differences are quite large. So we go from 10.38 to 10.53 to 10.82. And what are these differences reflecting? Well, in case one, we're just getting 10.38 versus the 10% quoted. And that's just really reflecting the compounding of interest because we're looking at effective annual rate. When we go to case two, we're getting that compounded interest. And in addition, we're getting extra 5 days of interest effectively because we're quoted on a 360-day basis, but we're getting 365 days of interest. And then in case three, we're getting effectively the interest paid upfront as well as the extra 5 days of interest. And so that is one way of thinking of the reasons for these differences in the effective annual rate. And then these are the formulas that summarize what we've done. So the interest essentially is calculated the same, but this will be different, the days and year convention. And then the interest may be paid at maturity, or it may be paid as a discount from face. And so the returns will be different, reflecting the interest basis. And then the effective annual rate formula essentially is the same for all the cases, but since the return is different, the effective annual rate we get will be different. So in conclusion, a large obstacle to understanding and making good use of the money markets are these different quoting conventions adopted in different countries and for the different instruments within the same country as we've just seen. Comparing instruments to others with different conventions, or also comparing them to bonds that are quoted on the basis of yields. We need to have some common standard, and those two common standards are the bond equivalent yield, which is the simple or uncompounded version, and the effective annual rate, which is the annually compounded version. So that's it for this tutorial on money market quoting conventions. Thank you for listening.